Okay, this one just starts off a little bit of an example problem that you might be able to use an equation to solve. And what it says is that the animal shelter is having a fundraiser. It's got a goal of $7,500, and this diagram shows the results for the first 3 weeks. Okay, at week 1, the amount is negative. They had upfront costs. Okay, in week 1, they're 500 below 0, and week 2 they're 500 above it. How much did it change? It went up by 1,000, right? And between week 2 and week 3, it went up another 1,000. Make an estimate, state any assumptions, and the basic idea is that what you can do here, and we'll leave that for later, is that you can model this by an equation. And an equation, unlike an expression, you know what it's equal to. We have an equal sign here, okay? And you can use an equation to represent a relationship between two quantities that have the same value. This is equal to this, right? So an equation is true if the expression on both sides is truly equal, okay? And an expression is false if it's not actually the case. 1 plus 1 is not equal to 3, so this is a false uh, statement of truth, right? And this is true statement. Now, it is an open sentence if there's variables, and so we don't actually know. By the way, this has variables too, but we know that x plus x is going to be 2x's. So 2x's is equal to 3x's. I mean, if x is anything other than 0, that's not going to be true. Okay, so we're going to say that that's false. But it's open if it contains one or more variables and may be true or false depending on the values of the variables. So we'll see what that looks like in a minute. But just know that you're going to have to identify something as either true or false, or maybe it's open if you're not sure. So we're looking at these and we're saying, are they true, false, or open? And how would you know? Well, if it's only numbers, we can actually just simplify all the numbers on one side and see if it matches what's on the other side, right? If there's variables, it's going to be open probably. So look at this right here. We have 24 plus 18. Is that equal to 20 plus 22? Yeah, they both add to 42. So it's true because this is equal in value to this. What about this? Is 7 times 8 equal to 54? Nope, 7 times 8 is equal to 56. So this side is not equal to this side. So it's false to say that they are equal. This is a statement of truth. You're saying this is equal to this. And that's a false statement. Okay, now, is this true? Well, it depends on what we put in for x. If we put in a million, is 2 times a million minus 14 equal to 54? No. Okay, but if we were to then say, let's say it was 34, well, 34 times 2 is 68. 68 minus 14 is 54. So it could be true if we put that number in, but it could be false if we put something else in. So you don't know, so it's open. Got it? Here's your got it problem. So the solution of an equation is the value that makes the equation true when you replace the variable with that value. For example, here they're asking to identify the solutions. Okay, is x equals 6 a solution to this equation? In other words, if we put in 6 for x, would we get 32 when we simplified this side? And you should substitute it in and check. And as you can see, when you do that, it doesn't actually work out to be equal to 32. It's 24. So we say no, x equals 6 is not a solution to this equation because this value does not give you a true statement. Try this got it problem. Okay, so we can use equations to find the solution to real world problems, and note that it says the word is indicates equality, okay? You'll see that come up. So here's the problem. An art student wants to make a model of the Mayan Great Ball Court in Chichen Itza, Mexico. The length of the court is 2.4 times its width, and the length of the student's model is 54 inches. What should the width be? So we know that we want to take the width times 2.4 to get 54. So here's all the possible choices they gave us, but what would the equation be? Okay, well, we know the length is 2.4 times the width, so if we say let W represent the width, then 2.4 times W should equal 54, which is the length. Okay, now test each answer to see if it's true. What does that mean? Well, what it means is that they gave you 4 choices here for possible widths. And so if you took this equation that you wrote, that the width times 2.4 should equal 54, you can actually plug it in and check, is 2.4 a solution to this? And it doesn't work out to be a true statement, so no, it's not. B, does 11.25, is that a solution? And when you plug it in, it doesn't work out to be true, so you say, no, it's not a solution. Is 22.5 a solution? Yeah, that actually works out. When you do it 22.5 times 2.4, it equals 54, which they say it should. And you do it again for the last one, 129.6 is not a solution. And so we say the correct answer is C. And that's the gist of it, okay? Now, what does it say here? Why do you need to test each answer choice? Because you want to be sure that you've got the right one, and if you try out your numbers and you did it right, only one of them is going to work if there's only one answer. So if you get 2 correct answers or you don't get any correct answers, then you need to go back and check your work and see what you're doing wrong. Okay? Here's your got it problem. Okay, so you can use mental math, and this is how you're going to do it. You see here, it says, what is the solution of each equation? X plus 8 equals 12. Just think, what plus 8 equals 12? And hopefully you come up with 4. And if you plug 4 in, you see that it works. Okay. A divided by 8 equals 9. What number, when you divide it by 8, equals 9? And hopefully you see that it's 72. And that's the basic gist of it. It's really pretty straightforward. So try this got it problem right now. All right, so we're going to use a table to find the solution of 5n plus 8 equals 48. And this note up here says, well, how do you know where to generally start your table? Okay, well, you can pick some numbers. What if it was 0? That would make that 0 plus 8. That would only equal 8. It's too small for that. Okay, what if you used 10? Okay, 5 times 10 is 50, plus 8 is 58. That's a little too high. And you'll find out eventually that this number right here is what you're going to be increasing by every time you increase n by 1. Because right, an increase of 1 here times 5 will be a total increase of 5. So 10 is too high, but we want to be somewhere around it, a little lower. So what can we do? We can pick some numbers that are a little bit lower, 5, 6, 7, 8, and plug them in. Okay, the table is essentially saying this. Here's n, some number that you're going to use for the variable, going up by 1. And then here's the expression, so then this is what it would look like when you sub that particular number in for the variable. Okay, and then you calculate it out, you get this, you do that, you get this, you get this, you get this, and you're looking for 48, so you can see here it must have been 8. Yep, the solution is 8. Okay? What's the solution here in your got it problem? Try it out. Make a table. Actually make a table and plug numbers in from your table. See if you can pick a good number. Plug your numbers in each time and see what you come up with until you hit the number. So the question that they're asking is, what's an estimate of the solution of negative 9x minus 5 equals 28? The idea here is that if it doesn't land exactly on the value, then what numbers is it between? And so we want to find an estimate, figure out what numbers it's between by making a table and then seeing what values of x get us on either side of 28. Okay, so to estimate the solution, we're going to find integer values of x between which the solution must lie. So when they throw in a couple of numbers, they put in 0 and 1 just to check it out. You get these numbers, negative 5 and negative 14. Notice that as you go from 0 to 1, you're increasing the value of x here. This is getting lower. It goes from negative 5 to negative 14. As x goes higher, your number is going further away from 28. It's getting lower. And that's because this is negative. So that means that if you want to be getting higher to get closer to 28, you're going to need to not go from 0 to 1 and up, but you're going to need to go backwards from 0 to, let's say, negative 1, negative 2, negative 3, so that as your x value goes down, the total value is going up closer to this. So we pick negative 1, negative 2, negative 3, negative 4, and we plug them in, each time calculating it out. And what we see here, since we're looking for 28, it's somewhere between these two numbers. So our solution is somewhere between negative 3 and negative 4 for x. The value of x that would get you this is somewhere between negative 3 and negative 4. Okay? Try this got it problem. Here's your lesson check. Good luck.